All right. Pull up your handout. What we've got here is a set of data, and this is, we've seen some of this in other examples and problem sets and stuff like that. What we've done with these data is gone through and grabbed gone through and taken a look and surveyed people on beliefs that they have about trauma exposure and its consequences. Okay. So again, these aren't people who have necessarily been exposed to trauma. These are just folks, right? This is just your standard stuff. So go through and ask them, give them a measure that says, has a bunch of basic stereotypes about trauma's consequences. Like people who've been exposed to trauma are dangerous and they're unreliable, and I would be hesitant to have a relationship with someone who's been exposed to trauma, these types of things, right? And so looking at some different stereotypes and things along these lines, right? But maybe what we say, and then so what we do with those responses and go through and run some fancy analyses, kind of break people up into three different groups. Groups here are going to be people who have generally sort of kind of benevolent beliefs, right? Sort of like, oh yeah, people are fine, they're sort of normal, they're sort of doing okay, things along those lines. People with overtly pejorative, sort of just like wild endorsement of pejorative stereotypes, right? And then we have some people who generally pretty good, like, so like, oh, it's fine with some interpersonal concerns about like sort of what I want someone who had been exposed to trauma, like sort of as a sort of caregiving for my child or something like that, or I would be worried about engaging in a romantic relationship with someone who'd been exposed to serious trauma, like some more specific to social domains, right? So we go through and we kind of break people into these three groups based on their responses, okay? But for this, maybe we want to know, you know, are there sex differences here? Do men and women respond to this differently, right? And there maybe is reasons to think, just based on socialization, that sort of maybe men and women differ in terms of the types of stereotypes that they will go through and endorse, and then sort of looking at differences across these different classes. So maybe it's not just what stereotype class I fall into, and maybe it's just not so whether or not I identify as a man or a woman. Maybe there's some combination of these two things that has impacts on sort of consequences for stereotype endorsement type thing. Okay, so we got ourselves set up in a 2x3 ANOVA. But again, with anything like this, right, the survey response, we're worried about, like, boy, are we capturing sort of actually things people believe, or is this just like, I caught Lindsay in a bad mood, and so she just said a bunch of really nasty things about people exposed to trauma, right? Or maybe Haley lands herself in the benevolent group, but that's just because Haley happened to be in a good mood today, right? So wanting to go through and say, think about, like, to what extent are these things related to just sort of state level affect, right? And so that's the data set that we've got. Does this make some sense? Okay, want to spend a lot of time on this because, again, for any of these analyses, the more you know and sort of understand the methodology question on the front end, the easier this is going to be to go through and sort of understand what's happening, what you got going on with things. Okay, so if you got your set open, what we'll do, and we don't have this in a handout, but we can go through and walk through a screening and start to kind of talk about, you know, what we might go through and note or find in this. So first thing I'm going to do is I'm going to go through and I'm going to look at, so we have positive affect and negative affect. And already off the bat, I've got a whole bunch of people, 32 people who we just don't have outcome scores for. Okay. So in my screening, probably what I'm going to do here, if you got sort of that level of missingness, you can just say, I don't know, 32 people didn't have scores. I mean, you don't have to go through and track individually who's missing what. So just kind of use sort of common sense to think about, like, this would be a tedious thing to go through and take a look. I mean, you might go through based on this because it doesn't look like we have class information on these individuals either. So probably you could just go through with this one and say 32 scores don't have PANAS data. And so we just went through and got rid of those folks, right? They're just going to go through and clear that. Go file. Save as.
Does it matter if the class is missing?
Well, and so that's what we're gonna do next. So we're gonna go through, so we've got all our positive affect and negative affect data, right? And now I want to go through and take a look at the class, right? Okay, so after I get rid of the people we don't have outcome data for, I've got 3 cases, 2 cases. Both women, I believe. Yep. Who we don't have data for. Okay. So I would go through and say, once we get rid of that, we got 2 more individuals, 2 women who we don't have a class status for. Are we concerned about this too much? Probably not. I mean, there's only really 3 ways this can go. They can both be men, they can both be women, or they can be split. Like there's not too much to infer from that. So I'm probably not going to be too worried about that. So I'll go through, note the participant numbers and sort of who those folks are, right? And then so say we've lost another couple of people. And so then that pretty much gets us where we want to be in terms of full data. Okay. Now, what I like to do with this is go through and just have a clean set that just has the people who I'm going to go through and analyze. If I were to run the model, it would have ran them with the same group, because if I'm missing scores on stuff, the ANOVA is not going to include those. But as I'm going through and screening, what's going to happen is I'm going to have sort of different subsets of the sample going into sort of calculation of different things, and then that kind of screws things up. So always what I like to do before I run an analysis, go through and say, here's my analysis set. Here's just the folks that are going to be included. Make sure I have documentation of why I pitched people if I did. Okay. So, all right, we've got our set. What do we need to do now?
Descriptives.
Need to do some descriptives. What do I need to do before I can start running my descriptives?
Split the file space by
Okay, split it by what?
condition.
Specific condition. Yeah. And so how many conditions do I have here, Jen?
6.
6. I've got 6 different subpopulations. I've got folks in the interpersonal concerns group who are men and women, in the benevolent group that are men and women, in the negative group that are men and women, right? So I've got 6 different subsets, right? So I need to go through and what I'm going to do is I'm going to go through and create a condition variable that goes through and separates my individual cells. Okay. Now there's a lot of different ways you can do this. For me, I generally will go through sort, right? And if you wanted to, you could even move this over so it's closer. Maybe I go through and insert a variable there, right? So it's kind of close. And then what I'm going to do is I'm going to set 1. And I'm just going to go through, pull this down. Copy that. Okay, there's condition 1. Condition 2. Looks like there's less people there. Condition 3. Or 5. Six. Okay, so this is kind of tedious way to go through and do this. It's manageable so long as you're sort of making sure that your rows are lining up. You're not sort of making any mistakes and things along those lines. Johnny, instead of that tab command, will go through and automatically do this for you, which is nice. Because yes, it's hard to go through and sort of impute like sort of large. I mean, you can do it. I can show you. Just hit sort of collect into just tell it what value to put in there, but it's a little less. There's a couple more steps that you have to do than sort of doing it here. But if you have questions, come find me with this. The one thing I would do before you go through and we move past this condition, I would go through and label this appropriately. As condition, and then want to go through and make sure that I know who's what. So 0 is women, 1 is men, and then we've got interpersonal, benevolent, and negative, right? So if I go through and I start, got women and men, okay. So what I'm going to do is I'm going to go to my condition, I'm going to go to values, right? And put 1. Women interpersonal. 2. Interpersonal. 3. Benevolent. And benevolent. 5. 2. 6. Okay. Making sure that you have your have these labeled appropriately on the front end, just so when you go through, because otherwise what you're going to do is you're going to start running your screening, particularly if you've got a bigger design, and trying to keep track of who's who with this is going to be a nightmare. So just go ahead and label this on the front end, save you a lot of time with stuff. Okay. So now I'm going to go back through. I've created my class or my condition variable. And so what I can do is go to data, split file by condition. Just go through, paste that in. Go to analyze descriptives. I want to look at positive and negative affect. My output, bootstrap options. We want to get skew and kurtosis values. Continue. Save, standardize. Paste that here. Okay. People follow me, see what we're doing up to this point. Again, just going to separate these out because with this factorial design, what I'm working with is 6 different populations essentially, right? And so I wanted to go through and make sure I separate those out. In terms of screening, this can be kind of a situation. It just requires you to go through and keep a lot of people in mind, but just go through, you know, follow, use the template that I've provided for you, but then also, you know, so here is screening for sort of one of the sets, right? So we just got 6 different groups, right? Just kind of going through and doing things. I appreciate the way people have been taking the time to go through and describe the distributions, not just labeling everything as unremarkable. But sort of going through and sort of talking a little bit about kind of what some of these distributions look like. Okay. All right. We up to speed with this? Okay. So you're going to go through, run this. I don't care about that. No. Well, so people have this up on their respective screens. So what are we seeing here, Olivia, in terms of descriptive statistics for positive and negative affect for women in the interpersonal concerns group?
Make it bigger.
What's that?
Can you make it bigger?
Yeah, I don't know that I can.
Because I'm behind on mine.
Oh, you're behind on
Yeah.
yours?
so I can't see.
So who has this up? All right, Jalen, let's go for it. What are you seeing? Is that a little bit better?
For the skew for the, it's, sorry, just to double check, it's split by the positive affect and the negative.
Yep, so we've got
Right,
positive
okay.
affect and negative. So these are our two outcome variables, right?
Yes.
Okay.
So for the positive, there's very little skewness. There's a little bit of negative kurtosis, and then for the negative, it's decently positively skewed, and then there's a lot of positive kurtosis.
Yeah, right. So we're pretty kurtotic, right? Positive kurtosis again is thin top, sort of thick tails, and a decent amount of skew, right? I guess, yeah, what about just take it away, Jalen. So what about men interpersonal?
The positive, once again, is like fine, but the negative is, oh. Okay, the like negative skew, it's like there, but it's still okay-ish, but the kurtosis is like a lot.
Kurtosis is a lot, and remember, like, so our benchmarks for skew is like 2, so even this is starting to exceed. Also, I would notice that for our women, we've got a lot more women than we have men here, right? And so we've got a kind of a small sample for men, right? So we're starting to become a little bit concerned with some of that stuff, right? Gabe, do you want to handle benevolent group?
I mean, where's women benevolent?
Yep.
I mean, it's okay.
It's okay-ish.
US kurtosis are a little high for negative affect, but it's under 3 standard deviation, so.
And so what I would sort of take a look at here, like you said, skew is 1.5, kurtosis is 2.5, right? That 1.5 is less than our 2 value, but it's still not great. And when we look at our graphs, you'll see that this is still going to have a clear positive skew going on with this. What about for men in our benevolent group?
For positive affect, it seems okay, but for negative affect, that kurtosis is like massive.
Massive kurtosis, right? Skew of 3.
Yeah.
Like that's really ugly data, right? And then what about Daniela? What about for our negative pejorative group? What are we seeing here?
For negative women, or those?
For negative, yeah, negative women and then negative.
Okay. For that one, for positive affect, it looks fine for both of them. Oh, it looks pretty good for women, positive and negative.
Yeah.
Affect. And then for men, it looks like that kurtosis is big for negative affect.
Yeah.
And it looks pretty fine for everything else there.
Okay. Yeah. So skew and kurtosis is big for negative affect and so not. So already what we're seeing is it looks like I'm starting to see a little bit different pattern in terms of just the distribution of these scores across men and women, right? The men looks like they're tending to have sort of more skew into their data than the women are. And sort of men, so we just have fewer men in our sample, but when we get down here, the discrepancy between the number of men and the number of women we're getting in our negative groups sort of starting to balance out. So there's just lots of things going on. How do we feel about our cell sizes in general? They're fine-ish, right? Some of them are quite large, right? So the number of women in our interpersonal condition we've got a really nice set there. Men with interpersonal concerns is pretty small. Doing okay for benevolent groups and for negative groups. But what I'm seeing, we've got clearly have about unbalanced design, right? This is not a random thing. We're not randomizing people to different groups. This is just what people are coming in with. Some cells are bigger than others. Some cells are smaller than others. But we've got clear concerns with the observed distribution in these data. Now, are we necessarily worried, like, are we technically concerned about the observed distributions in our scores? Do we have any assumptions about the observed distribution of scores with these ANOVA designs? So we have a normality assumption. What's that normality assumption involve?
Sample distribution of sample.
Distribution of sample means, okay? Do we have the distribution of sample means here? No, we just have the distribution of observed scores. What are the two conditions which distribution of sample means starts to become normal? Got a big sample, right? And then what else? Population is normal, okay? I don't know what the population distribution of positive negative affect is in terms of these groups, right? It will likely be skewed, right? But if we have decent sized samples, right? Probably most of these are probably going to approximate. The one thing is this men in the interpersonal condition where we have our negative affectivity, we have clear skew kurtosis. And so we're kind of in a weird situation here where I might start to be thinking about, do we need to transform, or is this a situation where we might want to transform some scores and things along those lines? Okay. So let's go through and take a look, and we'll go analyze, descriptives, explore. We're going to go have condition be our factor variable, drop in our participant number, and then have positive and negative affectivity here. Plot my histogram. Continue. Paste that in. First, we'll go through and sort this to knock the split file off, and go through and examine my scores here. Okay, so going down through, taking a look, all sort of nice and good information here, but going to scroll down and again looking at my histogram. So here's positive affectivity for women in my interpersonal group. Kind of a bimodal thing maybe here going on. It could be something with the way SPSS is binning things, but I might note that this is sort of overall looking kind of normalish, although we might have some bimodalities that would go in here. I don't know if I have anything specific I would attribute that to, so I'd be a little bit careful, but just note that sort of the histogram looks a little bit bimodal. For my men, for my interpersonal condition, again, I only have 28 folks here. And definitely I can see some of that negative kurtosis, right? Kind of that boxy kind of look here, although it is symmetrical and sort of relatively normal. Am I overly concerned about this distribution? Probably not, right? Now, if we get into our women with our benevolent condition here, again, we've got kind of a bimodal thing for positive affectivity, which again is interesting. We've got kind of a peak around just a little above 20, and then another one a little bit about 30. Mandy, what's the biggest thing that we're noting here?
Well, we have like a peak, like 2 peaks.
Yeah.
And then there's also like one on an island. So we should
You've got someone who just super jazzed today, right? They're just kind of way out on. Olivia wrinkled her nose at the first.
I'm playing catch up. There's something wrong with my file. Was
Uh-oh.
not that.
But yeah, we've got a score that's kind of hanging out there, and this is, we already know this is probably someone who's going to come up in terms of a strong Z score, but already I would want to be maybe wanting to. I'm suspicious of that person on whether or not sort of one, that value was entered correctly, if it was entered in the data, or two, if this was someone who has a reliable response. If they just go through it, I might go through, if you have item level data for that person, if they just like capped everything out at the top, that might be someone who's just doing some semi-random responding, things like that. So someone I would definitely sort of probably I want to take a closer look at.
If you were to like look at the item level data for that and you did find that it was like 5, and like in your screening, would you write something like to the extent that you like checked and it appears
Yeah,
like,
I would say sort of, and like when this has happened and you always should be doing this, right? If you get weird scores, go through and take a look and see what's going on. And I'll often sort of pitch people back that was responding was not consistent or questionable responding or responding or things along those lines. It's just what you don't want to do is just pitch people who didn't act the way you wanted them to. But if you're going through and it's looking like things don't make a whole lot of sense, we'll talk about that in terms of multivariate outliers. I'm reporting hot, like sort of peak levels of depression and also the best quality of life of anybody in the sample. I'm like, ugh, maybe, but these two things don't really go together based on my understanding of what I'm measuring with people. So I have questions, concerns about the validity of your responses. So I'm going to go ahead and probably turn this person loose. Okay. So histogram for men. Again, kind of symmetrical, but we kind of got this flat tail again, a really nice evidence of kind of a positive kurtotic distribution where we got kind of this thin peak and then some flat tails. But again, not anything that's probably overly concerning in terms of the distribution. For negative or positive affectivity in my women negative group, we've got kind of a strange distribution going on. And then for men, it's kind of boxy here, right? So, and then if we go through and take a look at positive affectivity looks pretty fine. We've got some high scores, but nothing too much going on there. Okay. Oh, so this is all positive affectivity. Okay, so positive affectivity doesn't look too bad.
can I ask you a question about extreme values?
Yeah.
So as we've been going through some of these screenings, I've noticed that some of them might be like more than, like when we do like the Z-score part, that some of them might be more than like 3 standard deviations above the mean, but then like on the box plot, it won't show up as like a significant outlier.
Yeah.
What-
Because it's working with sort of the box plot is all median based
Right.
stuff, and so the others is standard deviation. What I'm more interested in you doing is in your screenings, noting things that are notable scores, right? So even here, 515, 580, you know, 580 might not be something I worry about too much. 515 kind of creeps up there a little bit, right? So just using this to be flexible. And so even if you've got a distribution that's really kind of nice and tight, and then someone sort of falls out on the edge, maybe it's a Z-score of 2.5 or something like that, but I might know, like, hey, I'm not super concerned about it, but this person did fall away from the rest of the distribution. I want to just go through and kind of check on that just to make sure that it's a valid score, that sort of an RA didn't sort of misenter it or something like that.
Sure. Okay, that makes sense. Cause I was wondering if we should put like more stock in one versus the other, but either way, it's just something to note.
Yep, nope, it's just a descriptive,
Okay.
right? There's nothing prescriptive, like, oh, things are more likely to go. Did you get it?
Yes,
Okay.
a row somehow got deleted and it was like, we can't do this. Your grouping is not there. And I'm like, I can see it's there. We're good.
Okay, cool. So, yeah, I mean, it's just kind of being flexible and thinking about sample size, what my distribution look like, what's the range of the scale, right? How many people do I have in there? People are doing a nice job of talking about that in screenings. So, all right, now, okay, now we're going through and taking a look at negative affectivity. Okay, Johnny, what are we seeing with negative affectivity for women in my interpersonal group?
There's a lot of positive skew.
A lot of positive skew, but things that are continuing to drag out there, right? Now I've got 110 people in here, so my assumption of normal distribution of sample means is going to still sort of hit normal, but this is not something that would be. We've all are almost kind of have, again, kind of maybe a different thing where we've got almost, it looks like we maybe have a couple of different groups where we've got one with a low negative affectivity and then kind of its own new distribution kind of going on here. So there's some weird stuff happening, right? Here for men, I've only got 28 guys in this, but we've got someone who's hanging way out there on the end, right? That, I mean, it's not so far out, right? If this score was like at 60 or the top of the mark, then I might be points away, but it's not so far away that I'm sort of definitely noting that again for my negative affectivity for women in my benevolent condition. Again, I've got someone who's experiencing high levels of negative affectivity, but again, we've got a strong positive skew. Same thing for the men, right? For women in my negative group, we've got kind of a weird thing going on. This is probably more an issue of how SPSS has been this than anything else. But we've got clear negative skew here and clear negative skew for the men. And then if I look at my box plot here, we've got all sorts of stuff that's happening going on, right? So how are we feeling about our observed distributions based on these scores?
That's ugly.
Yeah,
It is ugly, right?
I wanna throw up when I look at that.
Distribution may more cute, right? So we've got some stuff going on here, right? So the question is it's not perfect. It doesn't look pretty, but is it a problem, right? Again, with our means-based tests, our normality assumption involves the distribution of sample means, not the observed data, right? And for most of these cells, I've probably got enough in there that I can probably reasonably assume that the distribution of sample means is going to be normal given the cell size, but I've got one that's pretty low, you know. But again, if we go back through and take a look at you, sort of look at those graphs versus the actual skew values people that registered for those, even stuff that doesn't hit our sort of kind of benchmark of 2 is still noticeably skewed, right? So just recognize this. What you don't want to do is be like, oh, it didn't have a skew of 2. It was 1.9, therefore it's approximately normal. Like, no, it's not. Like, it's very clearly skewed, right? So we can say, we can talk about deviations from normality that are likely not problematic given our analyses, but we want to be very careful about how we go through and talk about this stuff. You know?
What does the circle mean versus the star?
Okay, someone want to help dealing with circle versus star on the box plots?
So the circle means that it's more than 1.5 times the interquartile range. And then the star means that it's 3 times the interquartile range, which is a significant outlier in quotes.
So it's just going through and sort of registering. Stata won't do this. It's all sort of dots out there, right? So, but this is just some notation for SPSS. But what we've got here is we've got clear skew, particularly for our negative affectivity scores. And so my big concern is wanting to know, are there cases that are going to start dragging that mean around and starting to influence things, right? All right. So let's go through and take a look at Z-score distribution. Z-pan is pause, pan is negative. Get rid of save. Get rid of skew kurtosis. Okay. I'm going to go through, resplit my file, and then run my descriptives. All right. Danielle, what are we thinking? If we're looking at our Z-scores here, for our women in our interpersonal group, anything going on with this that is worth noting?
I don't think so. The mean and standard deviation are supposed to be 0 and 1.
Yeah, so that's good. What about in terms of something we might identify as extreme values here?
Oh, for negative affect, we see, are you talking about the 4? For
Yeah.
the maximum, so it's more than 2 standard deviations.
Yeah, so we got someone who's for the negative affectivity, we've got someone scoring over 4 standard deviations for the mean, right? That's a pretty extreme score. Now we've got a large set, I mean, it's 110 people in there, and if we get large samples, we're gonna expect some scores to kind of fall out there, but it definitely is worth sort of noting and commenting on, right? And so what I would do is I would probably go through and track down that case and kind of say, hey, this is the person's what they scored, right? What about men in the interpersonal condition, Daniela?
Kind of like the same thing, like with negative affect, the 3.77.
Yeah, yeah. What about women in my benevolent group?
For that one. For positive and for negative, the maxes are pretty high.
Yeah, I mean, for this one, I would probably focus more on that negative affectivity score. I mean, if we think about Z scores corresponding to P equal 0.001 is 329. This one falls a little bit below. You could talk about it if you want, but in the grand scheme of things of what we've got in other places, this is still,
Consistent.
well, it's at least not sort of reaching the, if we were going through and like all of our other cells, like the max Z score was like 2.5, then that might stand out to me. But given the context we've got here, it's really kind of the least of our worries. So again, it's thinking about this in terms of relative adaptive, like, so what do I want to spend my time talking about? In this case, this is probably not something that's going to stand out to me so much. But again, for negative affect, we've got someone who's about 3.9 standard deviations from the mean, so probably worth going through and talking about that a little bit. For the men in the benevolent group, again, we've got a really high Z score for negative affect. Women in the negative group, that's actually looking reasonably well, right, relative to everything else. Men in the negative group, again, we've got a high score on negative affectivity, right? So these are all things I would probably want to go through and talk about. Okay. So going through, so what do we go through and make of this? And as we sort of take a look now, in terms of our Levine's test, we don't end up with a violation of homogeneity variance for positive affectivity, but we do for negative affectivity. It seems like negative affectivity is really kind of the culprit in this. It looks like that's the one that is kind of coming up as consistently problematic. And so we've got a whole lot of missingness, right? We just tossed out 30 some scores on the front end. So we definitely want to say, like, had a bunch of people who were missing data, so we probably want to account for that, right? Once we got rid of those, there's just a handful of other scores. That's sort of not so concerning, but wanted to probably account for why we lost a notable portion of our sample just due to sort of missing values, right? We've got problems with an unbalanced design, right? We've got 29 in our smallest group and over 100 in our largest group. That's pretty substantial, right? So that's something we want to go through and probably talk about. Like, the smallest cell is close to 30, so it's kind of ish okay, but it's kind of right on that borderline. Probably the bigger issue is the discrepancy between 30 and 110, right? I mean, in the grand scheme of things, it's like what is that? Like 3 to 1, 4 to 1 difference. So it's not 3.5. So like, I mean, so it's not the worst, right? Like, we'll talk about like unbalance is like 4 to 1 ratio in terms of stuff, right? So it's not, or well, our design will tolerate sort of a pretty big discrepancy there, but it definitely is notable, right? That means that any one individual in that group of 30 has far more impact on the analyses than any one individual in the group. So we can start to have individual observations start to sort of move around and stuff. So we want to talk about that. Homogeneity variance isn't an issue for positive affectivity, but it is for negative affectivity. Now we've got an unbalanced design and violation of homogeneity variance. If we start to question whether or not our analyses are robust to that, right? We talked about that sort of doubling down on violations, right? And we start to become concerned about robustness, and then also thinking about whether or not I can trust the mean squared error for my ANOVA to be a good representation of things, right? So needing to be thinking about that. The distribution of negative affectivity is really kind of wonky, right? And that's probably the biggest thing I want to be thinking about, like, how do I address this, right? Now, I could go through, my options are to ignore it. Can we ignore it? Is that a reasonable thing to do here? Haley, you're shaking your head. No, why isn't it a reasonable thing to do?
Because the, I would say just with how messy, I guess, the data is in terms of like really. Hold on, track back, okay. I lost it all.
Statistically, is this problematic? The distribution of these observed scores. Johnny, you're saying no, why not?
Because underlying assumption of normality is still.
Yeah, so our underlying assumption is about the distribution of sample means. So I guess that's kind of a trick question. Should we ignore it? Like, is ignore is like pretend it's not there? No, don't do that, right? It's something we need to
That's what-
acknowledge and distress, right? Or acknowledge and address. Now, is it something that we need to take action on, right? Arguably, you could say it's not technically a violation of assumption. We've got reasonably large samples. The one group, the men interpersonal starts to borderline on that ish, right? We have some outlying values. Are they values that are gonna ruin and sort of research askew the mean? Maybe not, right? I mean, so the PANIS, you can only have such a so high a score on the PANIS, right? And so they're not, I mean, they're not like orders of magnitude out, but they're still like 4 standard deviations, and that's quite a bit. Think about, are your cell sizes are kind of big enough to maybe handle that, but then maybe not, right? And so we could definitely make an argument for ignoring it, just moving through, but it is something to consider, right? Other thing we could do is we could go through and start like smoothing the data, right? So taking those values that are sort of at the top, particularly those sort of folks that are just kind of hanging out on the end and sort of separate from the rest. Like I've got one person hanging out like 50. I could smooth those data and say, you know, what I'm going to do is I'm going to still rank order, have that person be the highest person in the distribution, but I'm going to take that score and I'm going to reset their score to 1 unit higher than the next highest value. So, and this is a procedure called smoothing. What we're going to do is just kind of bring this in, right? The nice thing is if you've got one case that's way out there and you've gone through and you've looked at the data, and this is someone that I want to have in there, right? They're a representative person in the sample, but I'm worried that they're going to drag people way out. What we can do is smooth it, say, this is a person, what I did is they were, you know, 4 standard deviations above the mean. They're a member of the population of interest, but I'm worried about that dragging things out. So rank order, they're still the highest person in the distribution. I'm just kind of pulling them in a little bit, right?
So when you say 1 unit, like, do you mean like if the next highest was like a 22, you'd put this person at 23, like it's actually the actual like raw score you're looking at? Okay.
So can do that, right? And so this is a thing that people do. The downside is like, one, you're like literally just changing scores, right? Which feels gross to people, but like it is a thing it's a legitimate thing to go through and do. If you've got like, so 1 or 2, for some of these though, like, what you can get is a never-ending battle of trying to figure out what to do with stuff. So here, right, if I take this value and bring it in one next, now these 2 just become bigger, and then I need to bring this in. And so it can be an iterative, like sort of going through, and so you can kind of get caught in a trap with that piece of things, you know. So given sort of the nature of this, I probably wouldn't, smoothing probably wouldn't be what I would do, just because it would be, what it's gonna end up is me jacking around with way too much data and sort of assigning values. Okay. Yeah,
I have a question, just like, it reminded me when you said assigning values. Have you ever, or like, what are your thoughts in terms of on missing data with, items in a scale? Like if they like missed a couple items or something like that, or statements, putting in the mean score of those in the place that missing data.
We're gonna talk about that next semester. It depends on what mean score you're putting in, right?
Oh, okay.
If I have an extroversion scale and I've missed, if I'm sort of filling out the PFI and I missed an extroversion item or a neuroticism item, and you take the mean of my other neuroticism items and just substitute that in, that's a perfectly acceptable way to handle that.
Okay.
Taking the sample mean and dropping it in there, that's a terrible way to do it. So there's some, and we'll read a paper about sort of how to go through and do that. This is why, in terms of measure construction, scale construction, I'm a big fan of using mean values for scoring as opposed to sums. Because if it's a mean, so long as there's not a huge amount of the scale missing, I don't care if you're missing one or two, so long as it's an internally consistent scale, I'm just gonna score it with the data that you have, and I don't have to screw around with that. Now, if I go through and have a sum score, now I've got to think if I just score it and ignore the fact that you've missed it, now people with missing data are gonna have systematically lower scores. And then that's problematic, so I need to go through and prorate those items, which is fine to do, but it just is kind of a hassle, and then I gotta keep track of who I did, what values I put in, which is fine, but it's just sort of more an issue. But if I just score things as an average, it sort of saves me time and effort on stuff.
I was gonna ask, like, related to the smoothing thing, how extreme would a score need to be in order for you to consider using that method? Like if it was like 3 standard deviations above the mean and it was the only one
Kinda
that,
depends, right? I mean, if I have a score that's hanging out there that if I have this with 110 folks, I probably wouldn't screw around with this, because I mean, those, given how far they're, like, it's not gonna, going through and taking those two values and connecting to the rest of the distribution, it's not gonna do anything. It's not gonna have zero impact, so I'm not gonna screw around with it, right? Now, if I had everybody kind of down here,
Mhm.
and then I had a one, or then these are over here, then I might think about it, right? But sort of kind of going through and thinking about pros and cons, like what happens if I do this? What's the other thing I might do with these data?
Could you shave them off?
I could take like a censored approach and go through and do it. The problem is sort of with that, like I'm probably interested, like if I'm worried about, hey, the only thing that's driving sort of these classes are people who are having high levels of positive and negative affect, and I start cutting out all the people who have high levels of positive and negative affect, and then I find negative affect does it different, then I'm like, hey, hooray, but like maybe I just eliminated all the people, because those people were in terms of determining how I was classifying people, but now all of a sudden I'm pretending that those scores weren't there, so I've got some problems with that. What's my other option?
Transform.
I can transform, right? And probably this is the thing, these data make, Jalen wanna puke, Haley thinks they're quite ugly. In the grand scheme of like sort of dealing with data, this is actually probably kind of good. At least what's going on is that across my cells, they're all sort of skewed in the same direction. It's all kind of doing the same stuff across individual things. And so if I'm gonna have to have a data headache to deal with, this actually isn't too bad. And a transform would address this. This is exactly the type of thing that a transform does a nice job. We gotta have a uniform positive skew. What I can do is I can go through run a transform or an inverse transform or something like that. And what that's gonna do is it's gonna pull that tail in and it's gonna look a lot better. Like this will fix quite a bit if I were to go through and I mean, we'll just do it right now.
I have a question.
Yeah.
So when you're writing like your analysis, if you use a transform data, do you say that on there?
Yep, absolutely. And Mandy, I should not be talking about negative affect. I should be talking about log transform of negative affect because I'm no longer looking at negative affect. I'm looking at the log transform of negative affect. This is the problem. People go through and transform things in situations that don't require a transform, but then pretend they didn't transform it, but you did, and so it's a completely different variable. I know what a BDI score is or a PCL score is. I don't have a good sense for a log transform PC. Like I don't have a good head sense for it. It changes sort of the nature of that scale, right? So the impact transforms can be useful, but they also impact interpretability, right? And then that starts to become problematic. But I can go through an SPSS. So I just went to transform compute, and I'm going to create a new variable called ln negative. And I'm going to If I hit arithmetic, I can find the function. Here's my natural log. Natural log of negative affect. Negative affect ranges from 10 to 50, right? If you got 0 scores, you can't do that because you can't take the log of 0. But so this is what I'm going to do is create a new variable called ln neg, and this is going to be the natural log of my transform of negative affect. I'm going to hit OK. And now I'm going to go through, hijack that. So we go through unsplit, split that, and then run new descriptives with my log transform. Okay. How are my skew and kurtosis values looking now? Quite a bit better, right? And if I go through and I take this off and go to explore, go to find transform variable, okay. It still has some skew, but it's not as bad as it was, right? It's much more reasonable. It doesn't 100% fix it, but we're looking at something that's much more. It's not 100% fix, but it's looking better. And there are different transforms that we can go through and use with this. An inverse transform is actually works quite nice with this, just because we have nothing but free time. We're going to go through and go compute variable. Inverse negative. Calculate this as 1 divided by Panis. Now, same thing. Put my file. Then all of a sudden things are looking really good, right? If I go to analyze, explore, take a look at my inverse transform. Okay. So we got some skew. We still got some skew here. But now I have even less of those things that are popping out, right? What happened though when I used that inverse transform? It flipped it around, right? So now lower scores are represented, because what I did is I took, for extreme skew, inverse transform is just taking sort of 1 over the value. And so now scores that are very, very high are gonna be giving me a smaller number, and scores that are smaller are gonna give me a larger number. And so just remembering now that what I need to do is flip that around, right? So this would be a really nice transform if I just wanted to go through and normalize the data. But what I need to do now is remember that with this transform, now lower scores represent higher levels of negative affectivity. If I forget that or pretend it's not, that's not what's going on, then things turn into a mess, right? Yeah.
What if this doesn't work?
What do you mean?
What if like the log transform doesn't work? Do we do?
It'll generally make it better.
When do we do non-parametric?
Oh, well, we're gonna talk about probably rarely if ever. Honestly, like it's, if you've got reasonably sight, problem with non-parametric stuff is, it's just not as powerful. And it's usually non-parametric stuff, generally stuff we're doing with smaller samples, sort of like types of things. But generally, what will happen if you've got reasonable samples is a transform will get you close enough within the sort of bounds of things that you want to do.
I
Yeah.
have two questions. So do you talk about the fact that you use inverse transform, right? Second thing is, I don't know if this is like, is it, do we have to do this for the positive affect too, since we did it to the negative affect?
I wouldn't do
Or we could
that
just
because
do whatever
positive
we
affect
want.
is looking fine, right? There's
Okay,
not,
so don't bother with it.
yeah, yeah.
Okay.
What happens with transforms? So, and this is the thing, so I could go through and say statistically, in terms of distribution, this transform is kind of nice because what it did is went through and made things look a lot more reasonable, right? And so, and these are data that are gonna be more consistent with what we would typically think about going through and doing things, right? But there's no free lunch. The downside is now I got a bunch of scores. It's the goddamn inverse transform of negative affectivity, and I don't know what that means necessarily. It's much harder for me to go through and put together. And when I'm talking about it, I'm no longer talking about differences across groups in terms of negative affectivity. Now I'm talking about differences across groups in the inverse transform of negative affectivity. I now have a construct I don't understand what actually it means, right? And so we've got some interpretive issues. Now we take that and then take that even farther into some of the contrast that we're gonna do with this. Now I'm talking about the difference in groups in the inverse transform of negative, and who knows what that is. I mean, I can attach a p-value to it, but telling you exactly what it is, I mean, I can do it, right? I can say, basically, anytime we do a transform, what we're working with is a median-based analysis, saying like, if I were to go through and just stick with the log transform, right, where things aren't flipped around, I would say, basically what I'm looking at are there differences in median levels of negative affectivity across these groups, which is an okay thing to do. And then I could run contrast and say, well, it looks like sort of on average, so this group has higher median levels of negative affect than the other group, right? Anytime we do a transform, we're talking about median level analysis. Mean changes around, but the median is the center variable. This is going to change the shape of the distribution, but the order of people are always the same. The person who's first is always first. The person who's last is always last. The person who's dead center in the middle is always the dead center middle person, right? But what I start to run into is complications in terms of like, yeah, I can go through and do things to the data, but then telling Lindsay what that means in terms of things. Now, if I'm working in an area like substance use stuff, right? Or if I'm doing sort of like reaction time, like sort of types of data, things that are areas where the data are always going to be skewed. If I don't do a transform, that's going to be weird because everybody transforms and everybody kind of knows what the sort of log transform or something is, then that's fine. But what I see as problematic is what people would just start doing is if I have any skew or any kurtosis, what they'll start doing is looking at p-values for skew and kurtosis. If I got a reasonably large sample, p-value is just telling me whether or not skew and kurtosis is specifically zero. Do we care if skew and kurtosis is exactly zero? No, but what people do is like, oh, I have significant skew and kurtosis, right? And then go through do a bunch of crazy ass transformations, and now who the hell knows what you got going on, stuff like that, right? So again, having to think about judiciously what are the costs and benefits of this, right? So for these data, what I would probably do to preserve interpretation and be able to communicate exactly what's going on, I would probably go through and I would lean towards just relying on the assumption of distribution of sample means is approximating normality. And just note that, yeah, we've got some notable skew to these data and violations of normality. However, given the size of these cells, it's likely shouldn't be too big of an issue, right? And so we'll probably move forward with that. Now, if I wanted to, I could also go through and run these analyses with with transform data and with untransformed data. And hopefully what I would find is no big differences there. Like that's a nice way to double check to make sure, hey, if I go through and I run these analyses and I don't transform it, do I get the same thing if I do? It's sort of like a sensitivity analysis, and that's good. The downside is if I go through and I find if I run it one way and get something that I like and run it another way and get something that I don't like, then be like, well, I really wanted to do it this way the whole time anyway, just because it turns out like you got to be careful with that, right? But that's, I guess, between you and God and sort of whoever you make your data available to go through and run things, right? Like for me, the criteria is like, could I stand in front of colleagues who I respect and make a straight-faced argument for why the approach that I took was the best way to go through and analyze these data, right? So some things to think about as you're going through and doing this stuff. All right, how are we feeling about this? Okay, cool.
Are we gonna transform in spring?
What's up?
Are we gonna talk more about this in spring?
Yeah.
Okay, then it's spring.
Okay, all right, I thought you asked me if we were gonna transform Mandy's brain.
No.
Okay, I was like,
I'm gonna roll all my words together.
okay, yeah, no, I was like, I like Mandy's brain quite well. I don't think it's used to the kids. So let's not. All right, cool. Let's go through, take 10. Then we'll jump in and just run through the analysis and then finish up with some high school stuff.
No, I think that's like what Kate does, like when he asks you a question, he says yes or.
Let's back on. All right. Anybody have any questions about screening? I like this, and it was nice to be able to go through and kind of talk through this, just given the data was kind of funky. The more, like, we're gonna continue to do these all through next semester, so by the time you finish up, like, it's hard to know whether or not data are weird or not if you haven't looked at a lot of data. The more data sets you go through and take a look at, these screens can be pretty tedious sometimes, going through and documenting, but I do like the idea of like you putting on your consultant hat and sort of like preparing sort of a summary document for some client who's going to give you money, which they will, and quite a bit of. It's a sort of kind of a lucrative way to do things if you can tolerate the data. Sort of going through and doing that. And part of that is just getting new practice and things along those lines, make sure you're understanding what's going on with some of the screening, but also to just kind of give you different looks at different sets and kind of what data looks like. By the time you finish up, things that you might have raised red flags before probably won't, and things that you might have not recognized as problematic, like by the end of next semester, you're like, okay, yeah, no, it's kind of a weird thing, right? So it's just like all of this. I don't know, sort of the best way to get you to kind of internalize it than just kind of working with the stuff. So we'll continue to do that. But any questions about where we arrived in terms of the approach that we're going to take with this and sort of the rationale for why we decided to do that? Okay, cool. So let's go to our set then. And after we spent 10 hours sort of making decisions and describing data and things like that, we can actually run our analysis. To analyze, we'll go to general linear model, univariate, right? So first we're going to look at our positive affect, our fixed factors, sex and class, and we go to plots. Go through and put plots on or class on a horizontal axis, separate lines for men and women. Add that in there. I'm gonna look at any post hoc tests. marginal means. We'll go through and grab that. Continue. Options will ask for descriptives, effect size, homogeneity of variance. Continue there. And then paste. Okay. So go through, run our analyses here. All right, and then we go through, take a look at our the descriptives. This shouldn't be anything shocking because we just spent a whole bunch of time going through and looking at it, but always good to make sure to go through and make sure that the data that you think you should have in your set are in your analyses. So 2-to-1 discrepancy of men and women in this set. So unbalanced but not terrible. Again, discrepancy across class. Again, closer, well, about 2-to-1 from the highest to the smallest cell, but again, not terrible. So unbalanced, but not sort of ridiculously so. The problem is when we come down into and start looking at all pairwise cells, this is where we saw we've got a high of 110 and a low of 28, right, in terms of discrepancy. So across individual cells, we got quite a bit of variability in terms of representation. So something we're going to want to keep clear in our head, right? And go down through, take a look at my Levine's test. Do we have any do we have concerns about homogeneity of variance here?
1 second. No.
Nope. And pretty clearly so. Remember, like we've got a whole lot of people in this sample right now. We've got poor representations in some cells, but like overall, there's really nothing here to suggest that we have wild differences in terms of variability across my individual cells based on my Levine's test. So feeling pretty comfortable with that. But then as I go down and take a look at my ANOVA table. Okay, so what am I seeing here in my ANOVA table? What do I have evidence for?
No,
What's that?
nothing?
Nothing really, right? I do have evidence, like I got a really like a crazy F value for intercept. What is that crazy F value for intercept? What is that a test of? Anybody know? We talked about it briefly. You got a guess, Johnny? Makes you feel any better. It's not anything we're ever concerned with. Basically, this is functionally a test of whether or not the average value for the set is different than 0.
Something about 0.
This is just a test of like is our grand mean different than 0? Yep, it sure is, right? But it's not something that we would go through and sort of spend a lot of time or sort of have any interest in 99.99% of the applications, right? So yeah, what are our conclusions here for positive affectivity? Yeah. We don't have any evidence for differences across men and women in the sample. We don't have evidence for differences in positive affectivity across our individual profile classes or stereotype classes. It just looks like there's not much going on in terms of positive affectivity here, right? And we do have a reasonably large sample. Some of the cells are pretty small, but what if I go up here and take a look, Haley, in this descriptives table, where am I seeing, what are my means for my main effect of sex in this table?
For like, okay, sex overall.
Yeah.
Total.
Yeah.
Okay, it's in the bottom, like where it says total for gender. And then you're looking, wait, main effects for
Main effects for sex gender. where are those means located in this table?
It's total, right?
So which total?
Which,
Like. That, the bottom,
Down here?
right, yeah. 'Cause
Okay, is
You mean-
this for, I'm looking for, overall differences.
Oh, that's
in men and women.
interaction, right?
Well, if I'm interested for this main effect of sex, so collapsing across profile class, where am I finding, my means for the comparison of men and women?
Like, sorry,
Oh.
go ahead.
The total under female compared to the total under male.
So just right here, so you're right in terms of total, it's just sort of which total, so it's, overall for
Yeah.
total
Okay.
women, overall total men, right? And we've got a difference of 26.3 and 27.8. It's functionally the same, right? And then, Olivia, where would we find, main effects, for class or profile?
The bottom one, total interpersonal.
Right here, right? So we got 26.3, 27.2, 26.9. There's just no differences there, right? Those are our observed scores. If we want to go down through, because we had asked for marginal means, you'll notice that these are close but not exactly the same, right? So main effects of sex, main effect of class, and then your interaction sort of terms there. When you're going through and plotting things out, always go through for these designs, go through and give me your observed means, not sort of your marginal means. Differences in sort of how you want to go through and present those. If we're running like ANOVA stuff, or if we're working on actual adjusted means, then your marginal means are probably better to go through and report, because that's what's actually being tested. These are based on the model, these are predicted means, right? So it's a little bit different for your straight up just between group designs, just go through and plot out your observed, right? And so you see some differences here and like, oh boy, that's a real different thing going on here. But notice that the full scale of the y-axis here is about 4 points, right? So there's not anything going on. All right, so, well, whatever, that was boring. Easy to write up though. Well, we're gonna go down through, go to compare means, univariate, let's swap out negative affect for positive affect. Okay. We go through and run it. All right. Now we go through and take a look down here. Mandy, what do we got going on in terms of violations of homogeneity of variance?
Well, we're looking at the end.
Yeah.
I mean, it's similar to the last one where we have like the highest being 110 and the lowest.
Oh, no, homogeneity of variance, right? So not the descriptive so
Oh,
much.
sorry, the Libby's.
Yes.
Yeah.
Okay. I think it looks pretty okay. Yeah.
What do we really want to take a look, Danielle? Do you have a?
See the significant based on the
Oh,
mean.
the significant. Okay, sorry.
right.
I was looking at like,
So we got,
yeah.
so we got 0.005 here, right? Which would suggest that we do have evidence for a violation of homogeneity.
Yeah.
Homogeneity variance, right? So at least one of these, we have some evidence that sort of variability across these different groups in terms of negative affectivity somewhere in there, right? So now all of a sudden we've got an issue where we've got violation of homogeneity variance, we've got unequal cell sizes. It kind of throws a bunch of stuff into the mix, right? In terms of like, what are we going to do with it? So we need to be careful in terms of thinking about what are we going to do? How do we understand some of this stuff? Okay, because it has implications for follow-up. All right. If I go down through and take a look here at my actual tests, Johnny, what are we seeing here in terms of evidence for effects?
So we have evidence of effects for gender and class alone,
Uh-huh.
but not the interaction.
Okay, perfect. And so tell me what that main effect of sex means.
sex.
Sex, yeah, sex gender. So what does that main effect indicate?
Indicating that there's a difference for that. What is that called? Yeah, the negative across the genders.
Yeah. So ignoring class, right? Collapsing the cross profile and just only looking at differences across men and women in this sample, we're seeing differences in negative affectivity, right? Now, Johnny, do I need to go through and run a bunch of follow-up tests to sort of make a strong interpretation of what's going on there? No, right? Because I only got two. If I go down through and I take a look at my marginal means, which is they're going to be close by, I mean, but they're just right here. What's the specific nature of that main effect of sex here?
Just ask that again.
Yeah, so I've got a main effects of sex. That doesn't tell me anything terribly useful. What specifically is going on in terms of the interpretation of that main effect of sex?
Females are tending to score higher than males.
Yeah, so we've got women are scoring higher on some negative affectivity as compared to men, right? And that's pretty sure, and we already know we've got a p-value for that. We've got sort of means and things along those lines. What we can do is go through, and I will go to compare means, independent sample t-test, drop that. That's 0, 1. Negative affectivity, drop that in there. Do I need to sort of worry about what's going on in terms of p-value or tests and any of this stuff? No, just going to go down through. The only thing I'm going to go through is I can go through and use sort of the t-test function to just quickly get a confidence bound around my point estimate. It looks like men and women differ by about 1.5 points on the PANIS, which isn't huge, right? So we've got 1.5 point difference. Lower bound about 1/10 of a point, upper bound close to 3, getting close to 3 points, right? So we do have evidence for an effect, but if I go through and I take a look at my effect sizes here, what do I want to use? Do I want to use pooled standard deviation adjusted or delta? I would want to, anytime you're looking at glasses delta, make sure that you know what group SPSS is identifying as your base group. It gets tricky there. What's probably our best metric of effect size here?
It'd be Cohen's D, or just Hedges G without the correction.
Yeah, so without the correction, right? Just a pooled standard. We've got a difference in sample sizes, but we don't have no violation of homogeneity variance. We got lots of people in here. There's no reason to add a correction. The correction does nothing meaningful to it anyway, right? So we've kind of got there. And so we've got a lower bound on this effect size of 2/100ths of a standard deviation to close to 1/2 a standard deviation, right? Notice that even for a sample of 330 some folks, the confidence bound on that effect size is still pretty wide. Anything from functionally 0 to about a medium effect size, right? And this is one of the criticisms of how to calculating confidence bounds around your effect sizes, that they are so large. But I would say that's just telling you that our metrics of effect are, we have a lot of imprecision here, so we need to be sort of very careful about sort of thinking about how we're thinking about planning studies and things along those lines, okay? Well, again, only reason I'm doing this is just to sort of harness or sort of use SPSS to give me some stuff so I don't have to hand calculate it out. Given violations of or sort of unequal samples, violations of homogeneity of variance, I'm probably not going to try and get fancy and start pulling things out of mean squared error terms out of my overall ANOVA, factorial ANOVA to start calculating comparisons and things like that. Let's just work with what we've got here. Okay. So people see how I went through and pulled apart that main effect of sex and sort of went through and taken a look at that. Any questions about this? Okay. So let's go back through and take a look back up to this. And so what's the other thing that we've got going on in this table here? For our 2x3. We talked about our main effect of sex. What else do we have evidence for here?
I don't think anything else.
What's that?
I don't think anything else is
Okay.
coming up, but.
So again, take a look at our between subjects effects. What else do we have evidence for an effect for? So we've taken care of our main effects of sex, gender. What else do we have in there? Which are other factors?
Oh, sorry, yes, it actually is popping up for class, sorry, I misread that,
Okay.
yeah.
So we have evidence for some evidence. I mean, again, if we're going through and calculating S values and base factors, it's not super strong, right? I mean, we can count it and so just call it interpretable. I mean, it's not massive, but and what does that main effect of class tell us?
That there's some difference, or at least one of them, I think.
Yeah, so collapsing across participant sex, right? Collapsing across sex and gender, ignoring that. What we're seeing is we're finding some evidence of negative differences in negative affectivity across these different groups, right? Doesn't tell us where it is. Like here, we've got a 3-level factor, right? A factor with 3 levels. So we can't just, I mean, we can kind of eyeball the mean to kind of see where we might guess that might be coming from. But we can't sort of go through and actually sort of test out and sort of know necessarily exactly where that's happening. Okay. So what do we do here? And if we just go down through and take a look at our marginal means, well, we probably eyeball our marginal means and probably guess where that difference is happening. What does it look like? Jalen, what do you think? Looking at our marginal means for class, like we have a main effect of class. What's probably going on with that? What would you have to get? What would you guess if you were looking at this based on just the marginal means?
There's not really a difference between the interpersonal and the benevolent, but there is a difference between both those and the negative.
Probably, right? Or sort of this, yeah, because we've got, these are functionally identical. And then here, like sort of strangely enough, are people who said a bunch of like really endorse a bunch of negative stereotypes and say are also people who are scoring higher in negative affectivity, right? So just looking at this, I already kind of have a reasonable understanding of probably where that difference is coming from. But I would probably want to go through and sort of make some sort of test, right? So what are our options in terms of teasing this apart? Yep, we go through and we could go, now, do we need to go through and run a one-way ANOVA, a simple effects ANOVA to determine where those, whether or not we have differences across those groups?
No, we can
No.
just look at it.
Because we already got that, right? But what I might do is I might go through and request a one-way ANOVA, so it will give me sort of different things that I might want, right? So that I don't have to crank things out by hand, right? So what I will do here, and let's say on the front end that we predicted that sort of, hey, we're worried about, like what I'm worried about is that this pejorative class, that this negative class maybe isn't just actually capturing prejudicial beliefs. Maybe it's just, I've captured a group of people who are in a bad mood and so they just kind of endorse some stuff, right? So we're going to pretend that before we went through and ran this, what I wanted to do was compare. I specifically thought that I would have, if there were differences in negative affectivity, I would find that my negative group would have higher PANAS negative scores than the combination of my other two groups, right? So what I can do here is I can go to analyze, compare means, and go down to one-way ANOVA. Right, and my condition, my factor is gonna be class. Negative affect is my dependent outcome. I can go and sort of set up my contrast. So here, I have my negative class is my last class, right? And so I'm gonna go negative 0.5, add negative 0.5. Okay, three groups. I've got interpersonal, benevolent, and negative. And I'm saying that the combination of my interpersonal and benevolent groups will have a lower PANAS score than my negative group, right? Can go through estimate effect sizes. Now I want to be careful in thinking about how do I want to estimate the effect size for this contrast? Do I want to use the pooled standard deviation for all groups, or those pooled standard deviation for those groups involved in the contrast? Which one of these do I want to choose?
Make a difference.
It doesn't. I'm sorry. I caught Olivia's scrunched up face in the corner of my eyes. Like, yes, I think you were on the same page. It doesn't make a difference, right? It's the same standardizer because we're using the same groups here, right? But again, want to be very careful in terms of how I'm thinking about this, right? We have violation of homogeneity of variance somewhere. I imagine it's probably across these different classes, right? And so if I had a series of contrasts, I would probably maybe not want to just start throwing groups in if they're not involved in the specific comparison. So if I was doing pairwise contrast or comparisons here, I would probably say just use for whatever groups are in there. Now, if I don't have a violation of homogeneity of variance and everything's looking pretty good, then I might just go through. Yeah, variability doesn't differ across my individual cells. Just go through and use all of the data as my estimate of my variability. If I'm not seeing that there's strong evidence that there's difference across, right? But if there is, then I'm probably gonna go through, let's just keep it to the groups that are involved. So we don't get, say like for my, let's say I was running, differences across, let's say if I would have had an interaction where we have that looks like differences across class are dependent on respondent sex, we would have had an interaction there, right? And we know like that maybe my men who are in the negative have far bigger variability, but like there's not as much as like, so we would want to have sort of some of that stuff going on in there, right? So it doesn't actually matter for this one, but just make sure that you're being intentional in terms of what you're grabbing there. So then we're just going to go through options. We'll ask for descriptives, homogeneity of variance, just so that we're kind of see. Do I need to request a Welch here? Not really, because I already got the main effect. I already know it. The only reason I'm running through this module is to go through and get my specific comparison, so I don't have to sort of go through and do it by hand, right? So I'm gonna go through and continue. I'm gonna hit okay. So if I go through and take a look that yes, I do have a violation of homogeneity of variance across these different classes. So ignoring sex and just looking at my different classes, it looks like there is differences in within group variability and negative affectivity, right? I'm ignoring the ANOVA table because I already have evidence for my effect, right? So ignoring that. Although we'll notice, what was my p-value for my main effect of class in my 2x3 ANOVA? Anybody remember? Yeah, what was it, Johnny?
It's like 0.0322.
0.0322, right? And so again, remember that we're talking about our factorial designs as generally being more powerful, right? Because right here, this, and again, SPSS is giving this to me because it's the module I asked for, but I'm not looking at it and interpreting it because I already got the omnibus effect from my overall ANOVA for my 2x3, right? But what we know is that 2x3 ANOVA took variability that was attributable to participant respondent sex and it modeled it. And so it's not error variance, it's something that's due to differences in sex. And so we took that out. Here, all that just goes in your mean squared error. Like this is just within group variability that's not accounted for, right? And so you'll see here, this won't always be the case, but sort of it typically will. We'll see a slightly larger p-value here than we did for the factorial because we're partitioning out, we're modeling other variability due to systematic differences within our group, right? But going down through, taking a look at my contrasts, and then again, I'm going to go down through, not again assume equal variances, and so we do have evidence of a difference, and saying that here it looks like the my negative group is on average scoring about 2 points higher on the PANIS than the combination of my benevolent and interpersonal groups. Upper or lower bound is anywhere from about 0.15 points to about 3.8 points. So it's not a huge jump here. If I go down through and I take a look at my point estimate, my effect size here, it's about 0.3 of a standard deviation, right? It's consistent with the smallish effect, right? So again, it's not something that's massive, right? It looks like it is there. We do have some evidence for an effect here, some possible differences, right? So if I'm worried about this measure, is this measure actually capturing differences in stigmatizing beliefs, or is it completely due to negative affectivity, kind of state level affect? What are our conclusions based on this? What might I sort of hypothesize?
Can you repeat the question again?
Yeah, so again, so the whole kind of idea behind doing this, so we took response to this survey, this sort of discrimination, this prejudice survey, stereotype survey, and created some groups based on their profiles of responding, right? And we came up with 3 groups. We had people who were generally benevolent, people who had some interpersonal concerns about people exposed to trauma, and then we had folks that just straight up endorsed just kind of overtly pejorative stereotypes about trauma exposure, right? And so we're like, okay, kind of what we've done is we've gone through and sort of pulled out sort of unobserved groups sort of based on their profile of responding. But as so I'm a scientist, I'm like, maybe we just what it looks like. We got different stigma profiles. Maybe what we do is just we got people on a bad mood, and maybe it's just what we're actually got with this negative profile is not people who actually believe a bunch of negative stuff about people with trauma. Maybe they're just people who are like they're just in a really bad mood. And so what I want to do is look at differences in negative affectivity across these different profiles. And so when I go through and I take a look, it says, yeah, it looks like I do have evidence for higher levels of negative state, negative affectivity in people in my negative profile. So like, what do I do with this? What do I make of this? What conclusions might I pull from this? Relative to why I did the whole thing in the first place.
Is it possible to say that it is like they're being impacted by like the negative affect? Because we do have a decent size,
Yeah.
a sample size.
Yep.
So I would assume.
Yep, and I do have some evidence that says, yeah, so like we're seeing differences in negative affectivity. So state mood might impact responses to this, right?
But not all of them.
But not all of it. So yeah, tell me a little bit about that.
Yeah, so I feel like, yeah, it's possible to have some who may have been in a bad mood. But because like in general, due to our sample size, that wouldn't be like the sole reason
Okay,
for
so I like where you're going with this. Can someone kind of expand on where Mandy's sort of going with this interpretation?
So, oh, sorry, go ahead.
I was just gonna say, I feel like if it was something about the groups, then there might be some difference between the interpersonal and the benevolent, because those kind of measure different aspects, so it could be more of the negative thing than
Yeah.
a group thing.
So we got two of them that are like functionally identical, right? And then we got this negative group that's a little bit higher. Yeah. What are you gonna say?
I was just gonna, mine was like more broad, I guess, but essentially we found evidence that at individual levels of like the measure, so at the gender and the class level, that we see a difference between gender and negative affect as well as class and negative affect. But when you put the two together, we don't have and like there's an interaction.
So what we would say is probably based on in the absence of interaction, it looks like the pattern, the difference that we're seeing across my assumption is that the differences we're seeing across the combination of benevolent and interpersonal versus negative it's the same pattern. The graph is going to look the same whether or not we plotted it specifically for men or for women, right? If I'm going through and taking a look at this, it certainly says that, yeah, it looks like there are differences in state level affect that people report before they go through and fill this out. But it's a difference of about, like, it's consistent with a small effect. Like, I'm not seeing something here that if we were to ask me, hey, if you're going to go through and administer this measure, should you account for state level affect? Probably, right? Is this the only thing is this a confound? Is the differences that I'm seeing across these groups, is it completely driven by just state negative affectivity? I probably no. I mean, I'm not seeing enough there, right? If we had a massive difference and a massive change across this, I'm like, yeah, what I thought we were measuring was prejudice endorsement, but or stereotype endorsement. Well, what it was actually is just like people's mood, right? There's an effect here, but it's not a big enough effect for me to sort of probably say, oh yeah, for sure. Like this is the thing that's driving the whole thing, right? If state mood was collinear with my profile construct, I would expect a much larger effect size here. And then also if we're going through and taking a look at evidence for sort of this difference, we have evidence for a difference, but it's not huge, right? If I were to run a replication of this and it didn't replicate, I wouldn't be shocked, right? So again, trying to think about like, okay, what did we find? What does this mean for the question that we have? And sort of how do I go through and take information that I've got from the data to start to inform sort of reasonable conclusions? So absolutely, looks like negative affectivity is related to sort of this pejorative group that we found, and that they're sort of just kind of maybe feeling more angry or sort of negative when they're going through completing this. But it tends to be a small effect, not something that would probably account for sort of all of the differences that we're seeing there. That help kind of go through and understand. And again, if we want to go through and take a look at my partial A squared, right? It looks like class, my profile class is accounting for about 2% of the leftover about once I pull out variability that's due to sex, gender, and the interaction of sex and class, of what's left over, which is a lot, right? Class is still only accounting for about 2% of the remaining variability in negative affectivity, which isn't a lot, right? So I'm saying, reading this is saying like, yep, negative affectivity is related, but it's probably not, it's not something that sinks the whole thing. I'm not worried about, this is actually probably evidence for the validity of my measure as opposed to against it. Yeah.
Is that R squared and adjusted R squared calculating variability for the whole model?
Which one are you looking at, Johnny?
Like right beneath the table.
Oh, yeah. This is just basically running in a regression format, right? So yeah, if you go down through and take it, and that's a really nice look. Basically, sex, class, and the interaction is accounting for 4% of all total variability and negative affectivity. Is that a lot? No, that means we've got 95.6% of all the variability in negative affectivity that is unaccounted for by anything that we have in the model. Right? So even these factors that we do have, the majority of my outcome is still not accounted for, is unrelated to anything that we have in here, suggesting, again, sort of kind of pulling into the argument that, yeah, what we've measured here is not easily accounted for just as by state level mood. So this is a nice discussion, thinking about like, we get so much information from these models and sort of looking at sort of between the evaluating the descriptive statistics or sort of different models and effects and things like that. There's so much that goes into it, sort of things that can tell us all sorts of cool things or generate sort of cool ideas about stuff, as opposed to just, yes, I have an effect of this, I have an effect of this, I have a significant p-value X or Y. So kind of going through and taking this together to try and think about like, hey, what my data are telling me, what can I infer from this? Okay. All right. Questions about this, how we went through and worked on this. So here we've got a situation where we've got two main effects, right? And so what we're doing is we're just going through and working through. Now, if I had a completely balanced design with no violations of homogeneity or variance, maybe then for individual comparisons, I might think about like what I might, if I was really wanting to go through and maximize power, maybe I could start going through using some of those formula to go through and pull error terms from the ANOVA to construct some things and go through and take a look at stuff. But honestly, this is more what real data look like. That's fine if you haven't had any violations and everything turns out great. But as soon as you do, you start to lose confidence in sort of the results of those tests. And so just falling back on some of the tools that we already have. It's a more conservative approach, but it's probably okay in the face of compounding violations. Okay. All right, cool. So only other thing, we've got that a screencast of, I think it's a 2x4 ANOVA that actually has an interaction in it, sort of going through with a straight up post hoc comparison, like how do we go through and teach things. That's a screencast. Would definitely sort of recommend you take the time and just go through and work through it. Has anybody gone through and watched that? Okay. How long is it?
It's like 20 minutes.
Okay, so definitely sort of probably worth going through and sort of just seeing, looking at the approach. We go through Benjamin and Hochberg, right? Sort of talking about how that stuff goes out, just to kind of think about how to manage a bigger design, how we might go through and do it, what you do with it in the face of interaction. So definitely go through and take a look at that before you jump into some of these. So yeah.
I just had a question about this with contrast. When we are being told to like do it with contrast, are we running the original like univariate and then going back through and then running like one ways with contrast, or can we run contrast with the original
Straight out of the factorial?
Yeah.
I don't think, so the thing is originally there wasn't a way to go through an SPSS to request specific contrasts directly through the factorial module. And I think that's still true.
Okay.
So again, if you're going through and sort of what you want to do is think about what comparisons I need to make, and then splitting files and sort of running those simple effects sort of best. And again, the question is if I have a perfect design and everything turns out right, if I'm doing, Jalen, if you're going through and doing a nice sort of randomized lab-based design where you get to sort of randomize people and everything kind of balances out and everything's looking good, then sometimes you can capitalize on the full design and sort of do some of the stuff. Problem is data is dirty, and the way we do it, we end up with problems and stuff like that. So then we start to, you can certainly do that, but I start to lose faith that that's giving us some accurate estimates of what we want to do. And so this is often, I mean, this is an approach that's informed by some of the Howells writing in that text, and we give up some power, but probably have more confidence in the results that we're getting. Yeah.
So that made me think, like in this example, since we did have a significant Levine's test, when we're reporting like the overall statistics, like the main effective gender and class, would we still be reporting F values then?
Yeah, I mean, the other thing too, which we can now do in SPSS, which we couldn't do before, we can go down and go back to my model or a model here. Right, and I can go to options and I can request a test with robust standard error estimates, right? I don't need you to do that
Okay.
necessarily, just because it's a regression based model. We haven't talked about regression yet, but if we go through and we do it. So I mean, this is interesting, right? If I go through and I just sort of. Yeah. But I mean, I think this is a good example, I suppose, here, well. Hard to tell. Here, I'm using an estimator with robust standard errors. I'm actually not getting an effect for sex, right? The effective class starts to become more difficult to go through because you've got multiple effects because there's some contrast coding and things like that. But actually, if I run this model with robust standard errors, which we couldn't do before until sort of like last week, but now it looks like things aren't turning up, right? So again, I'm not asking you to go through and do that because we haven't gone through sort of exactly what this is doing. I don't want you just pulling p values off of something you don't understand. But this would be a good test to go through because we do have some multiple violations, and if we run it, everything else kind of washes out. So I guess good for me if I put together this belief survey and worried about negative affectivity, if I actually run something that counts for sort of violations that we see, the Levines, they kind of goes away, right? And so basically what this is doing is just running your analysis in a regression environment with robust standard errors. And then this is certainly the better way to approach this. But it's one of those things that's newer just because it's been around for a while. It's a different way to go through and do things, but it's sort of starts to become more accessible if they start putting modules in to go through and do it.
And so then, like in this case, if we did have like a significant Levine's test, would it just be something that you acknowledge, but then you like still go ahead and report
Yeah,
the?
and then so using that to inform how you go about going through and running your contrasts and calculating your effect sizes and things along those lines.
Okay.
All right, questions? All right, cool. Let's go through and finish by talking a little bit about some chi-square stuff. Tell this is old. It's like it's not even widescreen. It's old. It's grandpa's TV. All right. So we've gone through, talked about t-tests, z-tests, and t-tests, and independent sample, and paired sample, and one way and factorial stuff. But the issue with all of these is we're working with a continuous outcome, right? Throughout all of this, it's situations where I'm looking at group level differences on something that we can at least treat as a continuous DV, right? But again, what if all of my variables are nominal, right? This doesn't happen a ton, but for you psych and law folks, a lot of this is the case, right? Like I don't have a continuous outcome. I have, I'm looking at yes, no types of things, conviction, non-conviction, or is this person, so in this group was active, medication adherence related to relapse, right? So I've got medication adherence. Did they take their meds? Yes or no? Relapse, yes or no, right? SES related to geographical region, our background characteristics related to acceptance into programs, yes or no, right? We've got categorical data, which presents an interesting conundrum in terms of how we go through and approach this and sort of test this out. This is one of these things where there have been historic shifts like early on in psychology. Like this was the bread and butter. We just dichotomize things and turn things in and use some more simplistic or less complex analytic models, right? Then we sort of get some computer power, sort of more means-based sort of continuous outcomes. And now you see these a little bit less, right? But it's important to know, how do I go through and address this, right? So I've got situations where my variables are nominal, just categorical variables, right? Or I have horrible violations of normality and my sample's small, right? Boys and girls, different levels of classroom regression. Well, I got a really terrible outcome variable because I only have a handful of people who exhibited any type of regression. I've got everybody at 0 and then just like a small tail here, right? Are there within person differences in ratings of subjective horror in response to neutral to trauma relevant films, right? Like we got weird sort of distributions, right? And so maybe in this case, I am measuring something continuously, but the actual data I got does not make sense to treat continuously because it's either a, yeah, they did it or they didn't do it, right? So what we've got here as a solution is our chi-square stuff and Jalen, our non-parametric tests is sort of where this has generally been the bread and butter of stuff, okay? Chi-square distribution is determined by a single parameter, okay? So it's just our degrees of freedom here. Again, like F, like T, chi-square is a family of curves, right? Determined by your number of parameters. Okay, so we got chi-square 1, 2, 3. So we start to get different shapes. Down here is the formula for chi-square, which is pretty cool. Interestingly, chi-square is just the square of a z. So if you take all the values in a z table and you square them, it will give you a chi-square with 1 degree of freedom, I think, right? So there's a direct relationship there, okay? For chi-square distribution, the mean of the chi-square distribution is equal to your parameter k, your degrees of freedom. Variance in your chi-square distribution is 2 times that, okay? And this starts to get into, I mean, this is just bar trivia stuff, you don't need to worry about it a whole lot. But as you start to get into zero inflated regression models and things like that, so the distribution of your data starts to become relevant and this stuff will start to come up, okay? So different types of things that we can go through and take a look at. One question is a goodness of fit test or one-way classification. In this case, we're asking, do our frequencies in our observed data deviate from what would be expected from chance, right? So here, we've got just one frequency distribution. What we want to do is say like, hey, is the frequency of some outcome that we're seeing, is it different than what we would expect just due to random variation, right? So this is so one-way classification test. We've only got one variable. We're just saying like, hey, is this happening at random? If that's our question, this isn't something that comes up a whole lot. Our one-way classification, our goodness of fit test is a way to go through and take a look at this. Okay. Oh, okay. Therapeutic touch on what's going on with this. So this is like facilitated communication types of things, right? Like, so we're going through and say, we find like as people are like, I've got my hand on you, and so they're going through and allowing you to make the right answers or something like that, or something along those lines. Do we see a difference in our data? So we've got 123 that are correct, 157 incorrect. Is this evidence of an effect, or is this just sort of random variability that we're seeing in this? Okay, so here is what we observed. What we expect, if this is truly random, we should expect about even Steven across these two, right? Formula for our chi-square is going to be the sum of our observed minus our expected squared over my expected degrees of freedom is equal k minus 1. So here we've got 123 minus 40 squared over 140, 157 minus 40 squared over 140, right? We've got 2 groups, so 2 minus 1 is 1. So we've got a chi-square with 1 degree of freedom, a critical value of 3.84, right? Would have been nice if I would have put up what the actual test was. this isn't gonna turn up as notable. I don't think. We have Does someone want to calculate that out real quick? Yeah. Yeah, 7 squared over 140 plus 7 squared over 140. Add those two things together. What is it, Joey?
2.35.
2.35, is that what other people got?
I only got halfway through.
I trust you on this.
2.25, so we would fail to reject the null here, right, and to say the difference is that we're saying there appears to be no effect of sort of this therapeutic touch intervention. It doesn't seem to be doing anything. It's actually in the opposite direction of what we would expect anyway. Basically, data are saying that the data we're seeing or the responses we're seeing are not incompatible with the null hypothesis of just sort of things happening at random. Okay, so this is just our one-way goodness of fit test to say, hey, are the frequencies of something that we're seeing sort of happening at random? We could have more groups, right? We could have sort of do people choose group 1, 2, or 3, right? And so are the frequencies that we're seeing different than just randomly people picking things, right? So some ways we can go through and take a look here. Here just goes through and shows you where to go through and get that one-way chi-square. I don't know if this is because this is an old slide, but there should be a thing in there for non-parametrics, legacy dialogues, right? Like that's some old school stuff. You can go down through and pull that out there.
I think, is that the same thing now? Isn't it like cross tabulation? And then
You can get a chi-square out of cross tab.
okay, so this is like directly.
Yeah, this is just directly.
Oh, okay,
across.
at least you could do that.
Yeah. So here's the chi-square for your one way. And so this is usually a chi-square, you're using like a two, looking at dependence across two different things. This would be if you were just looking at, like, this is essentially a one-way chi-square.
Okay.
Okay. So yeah, going down through and taking a look. So here's so I guess here we're looking at, this is a good example. What we're looking at in this data set of 185 people, does family income occur at random, right? Do we have equal distributions across all of these different scores, across all of these different categories? We can go through run a one-way chi-square, and it's very much is not randomly distributed. Like it's not just the same thing across here. So we're just testing so whether or not an observed set of frequencies differs from what we would expect just from random responding. Not something that comes up a whole lot, but if it did, this is kind of what's happening. Okay, here's the chi-square we know and love, our chi-square test of independence. We've got two categorical variables. Do we see that those two variables are dependent on one another in some way? Okay, so I've got categorical X, categorical Y. Is the likelihood of X conditioned on Y? Is the likelihood of X being in one group versus another dependent on some value of Y? Okay, here we've got a contingency table based in frequencies in rows and columns. This is data I hijacked from Narina's labs, probably sort of given stuff. So, trauma, death sentences, and it's nothing but good times and sad. Defendant race, white, non-white, death sentence, yes, no, right? So what we're wanting to go through and say is so the likelihood of receiving the death sentence dependent on defendant race, right? Are these two things related to one another? Or are they completely independent? Okay. Again, here's how we would go through and calculate this. Our expected value is a function of row column or row total, column total, and the number of people in the cell. Chi-square here, degrees of freedom here, right? How we would go through, calculate this out if we wanted to do it by hand. And so here we would reject the null hypothesis, conclude that the variables are dependent, the likelihood of receiving death sentence is contingent on race. Like these two things are related to one another, right? Basically, again, with these chi-squares, it's all about testing. What did we observe? How does that differ from what we would expect if these things were just happening sort of at random, if these things were independent of one another? Okay. Effect sizes for our chi-square test, P coefficient, the association between two dichotomous variables. If I got a 2 by 2 table, right? A P coefficient is just a function of your chi-square divided by the number of people in your sample. This is equivalent to a Pearson correlation. We'll talk about that as we start in the spring. Okay. Kramer's B, if I've got larger contingency tables, if I got something that's not a 2 by 2, if I got a 3 by 4 or a 4 by 2 or something like that, the Kramer's B is your effect size. For a 2 by 2, they're equivalent. It's just sort of difference in expense calculation of this to include the inclusion of more groups. Okay. Interpretive standards for P coefficient and B, same thing as a correlation, because that's essentially what we're working with. Risk ratios, odd ratios, also used as measures of effects. Hal talks about this a little bit. Odds ratios are things people struggle with. We'll get good at them in class, but note that sometimes those are things that are reported. Okay. Using tests of independence, Haley usually cross tab stuff, going through and requesting that. Easy to go through, request that, request your effect sizes and things along those lines to get through tests of independence. Here, we're looking at maybe we're testing. All right. So what we did here is we're wanting to test whether or not our randomization works. So we've got 4 different conditions, right? This is data that we've seen before, and we want to see did our randomization sort of reasonably represent things. I mean, we assign them at random, but this thing's looking like random, right? So we've got men and women, right? In each one of our conditions, looking at how many we saw, here's what we would expect, right? And going through and taking a look, and we would say, based on my chi-square, that I have a very large p-value. So it looks like these two things. We don't have evidence that these two things are dependent. We fail to reject effect sizes infinitely small, not anything that would even make sense functionally correlation of 1 to 4, right? So just using this as a tool to look at comparisons across categorical variables, 2 categorical variables. Okay. Another thing, okay, that we want to do, and this is always the thing that gets a little bit tricky with. So here, what we've done is we've calculated to look at. Okay, this is nice because this is some data that we just looked at. If we look at belief class, those 3 examples, there's 3 classes that we talked about, and looking at the relation between sex, like is respondent sex independent of what belief class they landed in, right? So here we've got a 2 by 3 chi-square, where we've got men and women, individual class, go through, run the chi-square, we see that's a very large or very small p-value that says, yeah, belief class is not independent of sex. There are sort of sex-based differences on sort of the people's endorsement of different types of things. But then the question becomes, well, where does that difference come? Like, what cells are different than what cells? Like, how do we go through and tease this apart? Here is where we can go through and request some residual statistics, okay? And in SPSS, we can go through and ask for adjusted residuals here. And you'll see in our cells where we have adjusted residual, what that's doing, we can interpret that as a z-score, right? So if I go through and I take a look, it looks like based on these data, men are underrepresented in terms of the social concern group. Based on these residuals, it looks like women are much more likely to be classified in the interpersonal concern group, whereas men appear to be overrepresented in the negative group, right? So these adjusted residuals are just a way to go through and tease apart. If I do find a dependency across 2 categorical variables, how do I go through and kind of find out where that difference is coming from. Okay, so again, suggest males underrepresented among respondents classified as socially concerned and overrepresented as in the negative group. So just kind of, this is like functionally our follow-up tests for chi-square. Some assumptions for us, chi-square, we assume if I have only a small number of participants, we start to run into problems with coverage. We get 0 observations in certain cells, and then that starts to become problematic, right? So if I have small expected cell frequencies, that's a problem. Most common criteria is when we're going through and looking at SPSS, we'll start this. We want to have, when you set this up, to have an expected cell frequency of 5, right? It's probably not the worst if you violate it, but you're going to have power problems if you're don't have enough people to at least have an expected 5 people in each one of your cell in your community table. Okay. If I have a situation where I have small cell sizes, okay, you can ask for a Fisher's exact test, right? So if I have cells, if I go through and I request my chi-square and it's telling me that I have multiple cells where I have expected frequencies less than 5, I can switch over to a Fisher's exact, right? SPSS will do this for me. If I have, SPSS will give this to me for a 2x2. If I have more, if I have like a 3x4 or a 2x3 or something like that, there are online calculators you can go through and just punch in your frequencies and it will run that Fisher's exact for you. But this is going to be a situation, a non-parametric approach to dealing with the failure to sort of have adequate representation in cells. Also common in collapsed cells with a small number of observations, you can do that, right? Now it starts to impact interpretability, right? Because now I've got a conglomerate group with just kind of a hodgepodge, but if you can make that sort of justifiable in your head, it's one thing. Like, well, we've got 4 levels of my nominal variable, but sort of the 4th category is not represented well. And so I'm just going to collapse that with another one to go through and get it to something that I can actually go through and analyze. Other assumptions, we assume that our observations are independent, right? That one person's scores don't relate to another person. We'll make sure that we have something not present, that we go through and include that. Okay, so here looking at, hey, do I ask you if you favor year-long daylight savings time? Like here, like number of people who said yes, number of people who said yes here, and then I go through and I say, oh, hey, we've got a dependence, but like sort of this data only sort of grab the people who said yes. We don't know how many people said no, so that's screws with our ability to interpret much of anything there. So I need to keep an eye out on that stuff, right? So if I actually go through and I run this as, so instead of a 1-way, as a 2-way, yes, no, rural, urban, now I get a completely different sort of outcome, right? So needing to make sure people aren't playing fun with the data. Okay. So if I fail to account for non-occurrences, it invalidates the whole situation. And some iterator reliability stuff. Let's skip over that. We get to our non-parametric tests to finish things up here. And if I've got small samples, serious violations of normality, not significant skew, like I got things are really wonky, right? What we can do is switch over to some non-parametric approaches, and we can think about these as distribution-free alternatives. Like this here with non-parametrics, the distribution doesn't matter. It's a median-based sort of ordering, rank ordered type of analyses. We can sometimes criticize these as having less power than our parametrics. So Jalen, if you can use a parametric is probably a better approach just because it's going to have more power. But if my distributions are really funky, my cell sizes are pretty small, to the point where I couldn't actually trust the results of a parametric test, non-parametrics can be a way to go. Okay. So my tests here, my Mann-Whitney U is an alternative to my independent sample t-test. So if I've got 2 groups on some outcome and the distribution is really wonky and weird and things. And it was I've got a small sample. I did clearly violate assumptions. What I might do is you know what, screw it, I'm gonna go non-parametric, I'm just gonna do a manual EU here, okay? Wilcoxon rank some, alternative to my paired sample t-test, so it's just a non-parametric analog of a paired sample test. Russell-Wallace, my alternative to my ANOVA, okay? And so this is going back into some deep, like old school psychological tradition and stuff like that, where people did not have access to computing power and things along those lines. Experiments were generally pretty small. These are things that you can crank out by hand, absent a lot of power or absent like computing power and things along those lines. And Whitney, you is looking at just basically the degrees of separation between two samples. If I've got severely non-normal variables, this is a nice alternative here. Just kind of going through and sort of how we go through and rank things. My first semester as a graduate student in Buffalo, like my entire stat class was all non-parametric, like the whole thing, like just our instructor was like 1,000,000 years old, and like he just had like notes from like the 70s, and we just like cranked through. Like I didn't know what the hell was going on half the time. As a new graduate student, I didn't know I was supposed to have to go to all the classes. It didn't seem like we were doing stuff, so I just didn't go. And I was like, got in trouble for that. So I don't go to the classes. But it is so one of those things that's kind of lost to time. Like people don't do these types of things all that much anymore. But it is a nice tool to have in handy. Like you're not going to need this very often, but if you do, it's nice to have it on hand, right? So again, just kind of walking through the management view. Assumptions, okay, in SPSS, non-parametric tests, legacy dialogues, 2 independent samples is going to give you the man Whitney. Wilcoxon matched pairs signed rank test. Okay, again, alternative to a paired sample test, looking at the difference between the correlated samples. Okay, calculate a different score for each pair, rank scores. Assign positive and negative ranks, right? So here's my matched pairs, calculate the different score, so positive and negative, rank order these based in terms of magnitude, and then assign scores. Some of my positive scores, some of my negative scores, get that. And t-test is smaller than some, so we got my test statistic is the smaller of my 2 sums here. So I've got my test statistic is going to be 6. Compare that against some critical T. So just going through and calculating some of this stuff. And again, where we would get that in SPSS. And then across the Wallace again, it's a lot of just ranking scores, summing up, signing stuff. This H statistic is kind of gnarly, but you can go through. And so you can start to see how if I'm Professor Skinner and it's 1950 and I'm running studies where I've got 12 people in sample, like this gives me a tool to go through and be able to go through and start to try and infer some things that I don't have access to. SPSS is not a thing, computers aren't a thing, right? Like for running a regression model or a factorial ANOVA is going to be like a data intensive type of thing. So a different tool that still has utility is just not going to come up probably a whole lot in terms of things. Okay. Other non-parametric tests, Wilcoxon rank sum, sign test, Friedman's, Cochrane's test. Okay, you don't necessarily need to know or have these sort of memorized, but if you do run into a situation, we've got a data set where the distributions are just kind of all over the place, kind of at a loss to know how to go through and handle this stuff. Tends to be in situations where you've not got that maybe it's a pilot study where you've not got that many observations, right? I can't throw observations out because I don't have that many, right? And I'm not comfortable, even if I were to smooth things, it's like sort of looking weird. Transforming doesn't make a whole lot of sense. Some of these non-parametric tests, we've got for our basic sort of means-based tests, we have non-parametrics alternatives. These are nice to know about and nice to be able to go through in a pinch, say, hey, I am aware that this is a thing, and you can go through and use it. Nowadays, most of the time when you see people using this, it's not because they need to, it's because they've misinterpreted violations of things and said, I have significant skew in my data, and therefore I'm going to use a non-parametric alternative. Like, well, you can, but your significant skew is a skew value of 1, which it's not great, but it's not terrible, right? But they came up with a p-value, and so like you've gone through and made an adjustment that you didn't need to do, and it's actually a complicated thing. So knowing that, so the cases where you would need these tend to be outside of like your chi-square. The chi-square out of all this is the one thing that sort of does come up with some regularity. Just making up words, forgetting people's names. It's the last class. But just kind of know where this stuff's coming from. All right, questions on anything? All right, folks. Thank you so much. You've been fantastic. It's been a really great semester. Excited you made it through almost all, except I got finals the rest of this week, but keep working on this factorial set. If you haven't started on it, do so right away. This kind of pulls in everything that we've done all semester and sort of making sure that you understand everything we've done all year. Remember that this set is count for double points, right? So make sure that you take the time to get this done. That's what we do Monday at 5, okay? And then once you turn that in, you're ready there, okay? So let me know if you have questions, things come up, talk with Matt, talk with me. We'll get you set in the right direction, so, okay.
One question.
Yes,
When you say double points.
Yeah.
So how many points?
well, it just weighted, so it counts as 2 assignments.
Oh, okay, so it's not
See what I mean?
necessarily like if it was 150 point,
No,
it's worth.
yeah, like, and some of the people have asked me, be like, oh, well, so what are like sort of these assignments are like, there's more points on my sheet and sort of the score than other stuff. It's like, the ones with more points are also the way more difficult ones, so I don't know that you sort of really want me to go through. So we're just taking sort of your average score across that, so. This last one just counts for double. And so the reason I do it is, one, it kind of is like a final, it just kind of brings everything together. And then 2, if you got someone who's kind of like, it sucks to be at the end of the semester, if you're kind of right on the border and like really motivated, like, oh, I would like to be in this class or something like that. Like it doesn't matter what score I get on this, I'm kind of stuck where I'm at. So just making this, couple of reasons for making this one. So it'll just count in your average. Like we have 7 sets. I just calculate as if we have 8, and then your score for this last one just goes in twice, just to sort of kind of give a little extra weight to that. Yeah.
I was gonna ask, so would our midterm now be worth 30% of our grade?
Yeah,
Okay.
I guess, that's kind of what it will be.
Okay.
And so, and again, if anybody has concerns about that, sort of come and talk to me. I mean, I that was a pretty big adjustment. Sort of if you sort of scored lower on that than you wanted to, and we're looking towards a final to go through and bring that up. Come talk to me about it. We'll get it worked out. I don't want to leave anybody in a bind, but I think we'll be fine with that. Awesome. Thanks, everybody.
Thank you.
So knocking these classes off, you got your Tuesday one, you got your Wednesday done, one done.
I think we should. I want to